is congruent to DC. BC is congruent to DC. And then AC is congruent to EC. And then this is where I ask you, I say, okay, is there anything else that you see that could be congruent, either sides or angles? It's okay if you don't see anything, but that's where I'll start.
I don't know. I don't know.
Okay, so let's go to the proof side of it. BC is congruent to DC, and AC is congruent to EC. That's given. All right, so the given is always given, right? If it's given, that's the statement. The reason we're going over here, because now it tells you vertical angles are congruent. So the statement is there's some angles that are congruent. You want to take another look at the drawing over here and see if there's any angles that are vertical?
Vertical. Vertical. Is it like they cross?
Yes, to make an X.
Okay, so it's like the D and A and the B and E.
Yes, where they cross, exactly. So you use a little arc there to show that. That was part of the instructions there. So we have to actually give that angle. So I'll do it in red here. Angle BCA is congruent to angle DCE. The order of the letters does matter, really does, but as long as you kind of go down the same orientation, like one's the single tick congruent to the double tick congruent, that's how the order is consistent. And then from here, you have to give the reason the triangles are congruent. So our options are, snip those in. Our options are side, 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 angle, side. I'm snipping those in now. Angle, side, angle, 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 side, hypotenuse, leg. The last one only applies to right triangles, which we do not have. What do you have here? What is B to C?
Side.
Side. And then we've got an angle and then another side. So it must be
Angle side.
And there you have it.
Okay.
All right, on to the next one here. Okay. So this one gives you less information, unfortunately. It'd be nice if they gave you more, but JK is do people your age still use JK as sort of a thing that speak to each other? It was big when I was a kid.
Yeah.
Yeah. So some things stand the test of time, just like these proofs. I was doing these when I was your age. They never go. They're still in vogue. Now JM's the other one here. 2 tick marks, LM. Okay, so we're in good shape. And then this one's less filled in, right? But we know the first one is always given. And you just put the givens in there.
What
exactly
number the proof?
I didn't hear what you said.
Would number 3 be like the proof?
Yes, but we're going to give on the right here, we're going to give the reason, but on the left, it's the triangle KJM congruent to triangle KLM, which means you actually can put a lot in this without knowing how to do it. You can get a lot of partial credit there. So anything else that you see in this triangle that's congruent, sides, angles, and keep in mind, it's telling you reflexive property. So that means
they reflect.
Well, it's like when you look in the mirror, you see yourself. There's something that's congruent to itself.
Oh, yeah. Is it a reflection?
So look at this line right here. Do you see how it's part of 2 triangles? That's the reflexive. KM and put a little twiddle there, little thing. KM is congruent to KM or MK, I guess, if you want to switch it up.
Mm-hmm.
And just like in the previous problem, you have to decide, is it SSS, SAS, ASA, AAS, hypotenuse leg?
Side, 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 side.
Side, side, side. There you have it.
Okay.
Right. Next one is 30. I'm stalling because I can't get the snip. There it is. All right. Number 30. Hopefully you're getting a feel for how these are all very similar, meaning that there's this one's probably some variation of what we just did. Probably a little more work, but like the very first reason we've given. So you don't, nothing to do there. But we do need to mark it up. We do need to mark that angle G is congruent to angle I, and FH bisects GFI. So bisect means it cuts it in half. That means those angles are congruent.
Mm-hmm.
All right, so now that's everything for the given. We can put the prove, like you mentioned in the last problem. You can put that in. And one of the reasons you do this is it just looked less menacing. You're like, okay, well, there's only a couple of things I got to figure out here. All right, so we know that FH bisects GFI. We know that that segment bisects the angle there. Angle GFH congruent to angle IFH. Definition of what is this word here?
Bisects.
Bisector. And what are we bisecting?
Angles.
So it's an angle bisector.
Oh.
So the word is almost always in there that you need. It's almost always in there.
Okay.
All right, now we need something else to make these triangles congruent. Do you see anything that is shared with both triangles?
The F and the H.
Yeah, so you would say something about FH being congruent to HF.
Mm-hmm. Yeah.
All right, now put a little twiddle there, somehow indicate that they're congruent. What makes these two triangles congruent? What is the same in both?
The
In
side.
terms of, we got a side, what else?
Angle.
Anything else?
Side.
I only see one side, the side,
Oh.
but two angles. So is it,
Oh yeah.
is it
Side.
angle side angle, or is it side angle angle? And it's the order, like just kind of map around the triangle. Like imagine you're walking around it. What would the order be?
Angle.
Or going the other way is fine too.
Oh. Side angle angle.
Yes, it's either side SAA or AAS, but it's not this one. And if we go back and look at the list, I just want to grab it here because this one's a little bit awkward because you have to do it in the right order. Like you can't say, oh, it's ASA. it's no, the order matters. It's an angle followed by the side.
Hmm. Oh, oh. I was thinking that.
It's the one weird one. The other ones are kind of clear, like SAS is kind of clear. It's like a side angle side.
Hmm.
All right. Any thoughts on that for me with 31? All right. Just keep going here. We know that it's given. I like to put the givens in as soon as possible. Angle N and angle Q are right angles.
Would number 4 also be given?
Yes, exactly. NO is congruent to PQ. Sometimes they do that.
And I think I already know what number 3 is.
Okay, why don't you
Um, OP is congruent to PO.
a little thing there. Now, unfortunately, there is no ASS theorem. All
What is
right.
it?
So that we gotta do something else here. This too is very important because they're right angles. What kind of triangles are they?
Right. Um,
And then
oh,
the only theorem that we have is HL for right triangles.
um, why is it HL?
So HL only works for right triangles
Oh, okay.
of the so there's you can get into the nuts and bolts of it, like, well, why is it? But when you just to prove that the hypotenuses are the same, which we have, and that one of the legs are the same.
Okay.
So that's the reason triangle ONP congruent to triangle PQO.
Oh, was that all?
That's it.
Okay.
Sometimes we want it to be more than it really is. It's like, nope, we're done.
Okay.
All right, number 32. I hope this is the last proof. You'll have to
I
confirm that.
Yeah, it is.
Weird seeing it like, so I upload these to my Google Photos and on the business here, and like I just see them like one at a time. It's like when you don't have the ability to flip the page, you just lose this. It's disconnected completely from
Mhm.
reality. So,
Yeah. Okay.
all right, so we know that it's given. Okay, given ST parallel to RU, that's good. And then the other given is down here, SR, so we'll use double for that. All right, so now the if the lines are parallel, alternate interior angles are congruent. So that actually can be we got to be careful here about what angles. We really want to draw the triangles we're trying to show that are congruent. So we're trying to show that SRT is congruent to UTR. And notice that down here, it says that angle SRT, which is, I'll have to do that in the other color here. I'll do this down here. So SRT is congruent to UTR. So that's the number, the reason for 2 here is the same for 4, but what we didn't want to do is give the same angles in 2 as are given in 4.
Uh-huh.
So we want to show that the other angles are congruent. So to do that here, let me grab, I don't even know if I have another pen color. Let's use the regular old one here. So we're trying to show that this angle right here, angle STR, is congruent to angle TRS. The double one down there. So number 4 is the if lines parallel, alternate interior angles congruent.
Okay.
But sometimes you have to split apart the 2 triangles to kind of see the congruent structure. Right now, we just have that this angle is congruent to this angle and this angle is congruent to this angle. That's not enough though. We need one more thing to be congruent, hopefully a side. Do you see any sides that are congruent based on this?
SR.
SR is definitely congruent to TU, but there's no there's no side. Well, I guess you could use angle side. Okay, yeah, that works. I was thinking you would go to R to T because they overlap, but that does
Oh,
also work. I do think the problem is designed for you to use R to T, but your way would work. It's typically better to give them
what they
what they
want.
want. Yeah. And then to prove, we've got that R SRT congruent to triangle UTR. Angle, side, angle, because you have an angle, a side, and an angle, a side, and an angle. And sometimes it's helpful to label those, especially if you're not sure.
Okay.
Okay, so from here, there's a lot of options. Might be good to scan this over and say, okay, I think I can do this, or this I'm comfortable with, but no, I can't do that.
Can we do? Can we start from 13? I don't know what this is. Oh wait, maybe I do know what this is. Let's go actually to the front
Yep.
page, number 3 and 4.
Okay. Yeah, we'll go with 3 and 4.
Yeah, and 5 and
All right.
6. And I don't know if yeah.
Good. That's enough to get started. I'll ask you again in 5 or 10 minutes after we work through some of these. So the thing that you have to remember about for 3 and 4 is that the sum of the interior angles in a
180.
triangle is 180. Yes. So if you're not sure, it either adds up to something, in this case 180, or it equals something, maybe equals itself. So this is the kind of equation I think you can solve. Go ahead and solve that for X. Use a calculator as needed, and let me know what you come up with.
Mm, Um, well,
X can be negative. I know that it might be weird, but X could be negative.
yeah, I
If
think it's,
if that helps.
yeah, I think it's -3.
It is, yes. Because
Okay.
X is not the angle, it's just the number that creates the angle. So like
Okay.
if you wanted the angle is 71 degrees.
Oh, okay. I think I can. Hmm.
So it would be wise for you to try number 4 now on your own and see if you can do it without any input from me. And I think you can. Let's set up the equation. They're all the angles add up to 180.
X equals 6, right?
What? Yes, and the reason that worked is the missing angle has to be 50 degrees. So 6 times 8 plus 2 ends up being 50 degrees, which is exactly what we want. Perfect. All right. So did you want us to do 5 and 6 or move on?
We can move on.
Okay,
Just yeah.
that's fine. You're the customer. You tell me where to go. I don't recall what the next ones, 7, 8 or not.
Mm, um, yeah, this page, the 7 and 8. 7, I don't, doesn't, it looks confusing.
Probably looks worse than it actually is. A lot of times tests are just stressful, so you don't see things clearly. We made a chart some while back about basing the answer on sides and angles. And it was like all sides congruent, no sides congruent, and then some sides congruent.
Oh,
What do you notice about all 3 sides?
they're congruent,
And how about all 3 angles?
congruent.
So then the problem here is you have to know what that word is, and this is equilateral triangle.
Oh, that.
Yes, that's what they're looking for. Now there's like there's potentially more than one way to name it, meaning there could be like an angle on a side situation.
Hmm.
But remember, it's a final exam. They're not digging for like the most or the deepest knowledge possible. They're looking for general knowledge,
Uh-huh.
higher level stuff. It's like looking at a pizza and knowing that it's a pizza. You don't need to know that it's flour and water and egg and toppings. Okay, number 8. Tell me what you see in terms of sides and angles.
There's 2 sides and 2 angles.
So this is isosceles, 2 sides, 2 angles, congruent. And it's always that way. It's always 2 sides, then 2 angles congruent.
Hmm. Then 9 and 10.
Yeah. So let's take a look here. All right. The shortcut for doing this congruent statement is actually to look at the triangle letters and see where F and D fall in the first language or first triangle. So see how it kind of wraps around F to D.
Mm-hmm.
So we're looking for the wrapping around from I to K. So the answer is I to K, but let's also look at it on the picture there. So F to D goes from the third, the third angle, the three of them there, to the one angle, one line angle.
Mhm.
So then does I to K do the same thing? Does it go from the triple angle to the single?
Yeah.
Yes, yes. So there's two ways to do it. It's to use the mapping of the letters, basically the order of the letters. It's in an
Mhm.
order, or to go and look for it. But it would be wrong to say KI. If you said K to I, that would be wrong. The order matters.
Okay.
So 10 is a little bit easier because it's just asking about an angle, and the angles match up letter for letter. And what I mean by that is, you go back to the original here,
Oh.
D goes with D, E goes with X, F goes with R.
R. So it's R.
Yes, and if you were like really uncertain, you could do it graphically. You could be like, okay, F is between E wrapped around the D. Okay, and so you'd almost like it's this angle here, and then S wrapped around to
Mm-hmm.
D. Okay,
Is 11 and 12 the same? Or
you have to write. It's like they're 11 and 12 are more difficult because they're not giving you the statement. You have to derive the statement.
okay.
Would you like us to work on those?
Yeah.
Okay. All right. So 11 is you got to find a starting point. Okay, so I'm going to choose the one angle as the starting point, and then you create a path. So I'm going to go to the two double line one, and we're creating a path up to the three double line one, and then back down.
Uh-huh.
And so that's triangle BCD. It's a path, we started at B, went to C, and then went to D. We
Mm-hmm.
want to take the same path on the other triangle. So you're starting at G. Where are we going from G? Are we going to H or I?
H.
H, and then to I, and then back to G. And there you have it.
Okay. The next one, is it um PQR and then QPD or no?
I'm just getting it written down because I was getting touched up. So again, it's a path P to Q to R. That looks good. And then QPD. Yes, those are good.
Okay.
Got it.
Then, hmm. Can you just explain this page to me?
Which one? Sorry, the
The
19.
the 13,
Sure.
14, 17, 18.
All right. So 13 and 14 are just labeling the stuff that's congruent.
Mm-hmm.
Basically, like in the previous problem, they already labeled the sides and the angles and all that. You have to do the same thing here. You have to say that, like, I'm probably this one on the right's easier, but to explain, but it's like J is congruent to J, for example.
Yeah.
And then you have to do the same thing for I and C. So maybe like two letters for I, two for C, sorry, two little arcs. And then K gets the triple arc, B gets the triple arc. But you also have to do the sides, and you want to follow that path. So it's like J to I it's congruent J to C, J to I, J to C, I to K, C to D, K back to J is D back to J, like that. And there's a couple of different there's a couple like if you preferred to start at like K, you would have a slightly different picture. So these are kind of hard to grade for the instructor. They're probably not going to have you do this on the exam. They'd have
Mhm.
to look at every single one. Is your final exam typically a multiple choice or free response or both?
I think it's multiple choice.
Yeah, so this would be really hard to do as a multiple choice. But having said that, so 13 is the same way. Do you want us to do 13 or do you feel like you have it?
Mm, can we do it?
Sure. So I want to start with the L and the B because they're the ones that are kind of far away.
Mm-hmm.
So we're kind of starting at L and B, one line each. And then we're going to the next one, which is, it says C. So and for the first one, you wrap around, your next angle is C. So that's referring to this angle C here.
Mm-hmm.
All right. And then the other one is L to C. So it's this angle here.
Mm-hmm.
And then so it must mean that the other angle gets the 3.
Okay. And for the bottom, like, oh, we'd still done.
Well, yeah, you still do the sides. So
Oh,
like you might say, okay, the direction from 1 to 2, from 2 to 3, and then from 3 back to 1, something like that.
okay. Okay.
All right. So any questions on that before we move on to 15, 16 or 17, 18 or something else?
Just 18. Yeah, just 18.
Okay. Grab a snip. All right. So it says isosceles and equilateral triangles. We don't know which one, but there's enough information here to find X, supposedly. Like we have to do some things to find it. This top triangle is an isosceles triangle.
Mm-hmm.
And we mentioned earlier that if it has the same sides, that means it has the same angles.
Yeah.
So the base angles are congruent. Will you find this third angle for us, please? Keep in mind that all three add up to 180.
Mhm. 50.
It's 50. And that means that it's 50 in this other angle or other triangle. The other triangle is drawn a little oddly, but it's still isosceles. The two congruences tell you that the base angles are the same. And one base angle is 50 and 50.
Oh,
And that allows you to find that missing angle X.
80.
Yes.
Okay.
So there's kind of a path to getting it. And you'll be able to do 17 for sure on your own.
Yeah, I did those.
Perfect. Okay, we've got some time left here. Where would you like to go from here?
Number 25 to 27.
Great. Okay, I've got 25. Let's snip it in. All right, so 25, we're trying to find the question mark.
Oh, that one's easy. 50. Is
Well,
it? Oh wait,
it's
never
not
mind.
50. Yeah, I was gonna say it kind of looks like an isosceles, but unless it gives you that.
Yeah.
This angle is 60 though, because a straight line angle, they always add up to 180. And then
Okay.
there's enough information to find the other one in the triangle.
Okay. I can finish that one.
All right. Where to from here?
Um,
26. There's two 26s. So the first one, maybe.
oh, the second one.
Second one. All right. The second one. Okay. So there's a shortcut here, which is that this exterior angle equals the sum of the other two angles.
Mm-hmm.
If you don't think you would remember that, we can find this angle in here and then add them all up to 180. What would you like to do? Would you like to use the shortcut or just
The
find
short.
this angle? Okay. So the shortcut is 8 plus 6x equals 30 plus 4x plus 2. So on the right, we can combine like terms, 32 plus 4x. And then solve for x. So subtract 4x from both sides, subtract 8 from both sides, 2x equals 24, divide by 2, x equals 12. Okay. Now that's the solution, but sometimes they want you to put that 12 back in to find the angle.
Mm-hmm.
And especially if it's multiple choice, make sure it says solve for x, not solve for angle q,
Yeah.
because that they might both be there.
Uh-huh.
And you'll say, why didn't I,
Yeah. Um,
maybe time for another couple of questions, just depends on how short or long they are, or maybe we've gone through everything.
did we do questions like 19 and 20?
Kind of, yeah, kind of, because we did them in the proofs where we had to say whether they were congruent or not. So in 19, we know that this other side is congruent.
Mm-hmm.
Okay. And what we can do, although we're not sure how exactly it is, but if the two legs in a right triangle are congruent, it
Mm-hmm.
the no choice theorem, I don't know if you've heard that, it sounds really awkward. No choice theorem says that the third side must also be congruent in
Uh-huh.
a right triangle. So you now have hypotenuse leg for congruence. But you might check if you're allowed, if that was the intention here.
Mhm.
But I think it's reasonable, because if A and B of the triangle are congruent, then C must be as well.
Okay.
For 20, you don't have enough information.
Mm-hmm.
And the reason is you don't know, you don't have a leg. You have the hypotenuse part. Check,
Mm-hmm.
check. You need a leg. But having said that, if one of the angles are congruent, again, by no choice, the other one is also congruent, which then
Mhm.
gives you congruence using something else, but you can get it that way as well. So I guess the answer is yes to both, although I'm not sure they met this, so you might double check with these.
Okay. Mm, okay. I think I can finish the rest.
Awesome. All right. So let me go ahead and stop the recording. All right. Any idea where we're at for next week for lesson? I'm just so busy. I want to make